Welcome everyone, please, to the Expert Masterclass, Bridging the Cloud with Virtual Network Pairing, what we at Simplilearn like to call it a Learn It Live session. Today's instructor is Purushottam Asudani, who is an assistant professor at SRCEM. I'll tell you a little bit more about him as I introduce him in a moment. First, I just want to remind everyone, if you're not familiar with WebEx controls, you'll find a button or function for Q&A. That's where you should put in questions for Purushottam, and we will take those at the Q&A section toward the end of the event. You can chat to the host and presenter panelists if you wish, but we're basically monitoring the Q&A for questions. And we're also going to be doing a couple of polls, one at the beginning, one at the end. So we'll start with a simple 2-question poll. And this one is, what's your current job role? So are you in cloud computing currently, in the related fields, DevOps or software development? To get a feel for the audience. Also, how are you doing today? We've been asking this since the beginning of the pandemic, just to keep track of how people are responding to lockdowns coming and going and surges rising and falling. Got about 5 seconds left on the poll. And here is the result. So about half of the audience today are students, and a smattering of people in other roles. And it's good to see that nearly everybody is doing well or doing okay. So hopefully this event will help improve the outlook for people who are in the third category. With that said, let me introduce Purushottam. First off, my name is Stuart Creek, by the way. I'm a marketing manager here at Simplilearn. Purushottam Asudani is an assistant professor at the Sri Ramdev Baba College of Engineering and Management in Nagpur. He specializes in cloud computing and operating systems, and he has been named a Google Scholar. We're extremely fortunate to have him on our faculty of trainers and here today. So welcome, Purushottam, and I'm going to stop sharing my screen and let you share yours.
Thank you, Stuart. Thanks a lot. Yeah, I am going to share my screen. Yeah, thanks a lot. I'll just share my screen. Hello, everyone. Welcome to Simplilearn. I am Purushottam. So a very warm welcome to all of you guys. And thank you, Stuart, for giving me this opportunity. And guys, so a very good morning to all of you. Rather, for me, it's good evening, right? So I welcome every one of you out here. So, yeah. So we will begin for the day. So I have many participants here, basically. So I'll quickly name them if I would be good to. Yeah. So if I miss some, kindly forgive me. Divine, MD Raj, Ganesan. Just a second, guys. Yeah. Abdul, Abhi, Abhijit, Abhishek, Abid, Aditya, Akash Kumar, Akinola, Akshay, Alex, Ambrish, Amitesh, Anand, Ankit, Anushka, Arif, Arthur, Arti, Aruna, Asadullah, Ashish, Aslam, Asmita, August, Binaya, Bhavesh, Vijala, Gozara, Carlito, Kem, Chabog, Chetan, Dada, Damayan, Darren, Daryl, Deepak, Danis, Musiko, Divine, Dinesh, Divya, Doris, Elango, Elizaveta, Eugene, Fahim, Fruzail, Ganesh, Giri, Gopi, Helri, Anand, Harshini, Hilaria, Himanshu, Hoy, you, Idrissa, IDW, Iman, Invisible String, Jacqueline, James, Jamil, Jeevan, Jeremy, Jalak, John, Jigar, Joshua, Chumana, Kajol, Kalika, Kamil, Kanwal, Karthikeyan, Karthik, Kasiranjan, Khalid, Komal, Krishna, Kritika, Lasya, Lakshmikanta, Labo, Luzman, Muhammad, Madhwa, Madhumita, Manikandan, Manish, Mark, MD, Raj, Mekonnen, Jake, Mini, Muhammad, Mohit, Monimola, Murli, Nityananda, Naga, Nihet, Neet, Nikita, Niranjan, Nirmal, Nitya, Nitish, Nurja, Odu, Ole, Olu, Osama, Piklu, Prabhat, Pranav, Prasanna, Prashant, Prithis, Priti, Raghavendra, Raj, Rajesh, Ramesh, Ravi, Renuka, Richi, Rick, Rizza, RLjit, Roger, Ron, Russell, RSV, Sai Kumar, Sai Rama, Sai Reddy, Samar, Sanam, Sandeep, Sandesh, Sangi, Santosh, Satish, Satyam, Saumitra, Sera, Shadab, Shamas, Shanghai, Sarad, Shilpa, Shobna, Sobit, Sri Hari, Shubham, Siddham, Simran, Sinok Zola, Sonal, Scarlett, Sora, Soumya, Srika, Srinivasan, Stuti, Sudeepan, Suhas, Suryansh, Sushmita, Swapnil, Selvamani, Tebojo, Udit, Umidi, Usman, Vedya, Vaishnavi, Vedi, Vinshika, Venkatesh, Vedansh, Vidya, Vignesh, Vince, Vishakha, Jonathan, Yusuf, AJ. Welcome everyone, guys. Nice to have you all here. I'm privileged to have you all here. So let me quickly write down. I am Purushottam and rightly stated by Stuart. He has given already my introduction, so I'll not waste much of your time in that. Yeah, just to tell you, I am 3 times AWS certified and I'm a Google certified cloud engineer. I am a Microsoft certified architect. I am 3 times on AWS certified architect professional, and I am AWS certified trainer, Microsoft certified trainer. Yeah. So yes. So quickly, I'll not go to the deck and will not introduce you much because already I'll not waste much of the time here and will get into the stuff. So I'll quickly write down the agenda. So, as rightly pointed out by Stuart, we'll be studying about VNet peering, guys. VNet peering. So, bridging the cloud with VNet peering. Yeah, so that is going to be the agenda for the day. Yeah, so let's begin. Yeah, so we will just begin. Yeah, just a second. Yeah, chat window. I am seeing here. Okay, right then. So, guys, what is VNet peering basically? So, basically, VNet peering is nothing but a connectivity option. Like with VNet peering, you can connect your two virtual networks in Azure. Okay, so if you have to connect the two virtual networks in Azure, well, you can do so with something called as VNet peering. Okay, so uh, when you have a virtual network in Azure, so inside that you also have a subnet. So let's say if we have two virtual networks, that is VNet 1 with a subnet and VNet 2 with again a subnet, right? And let's say inside this VNet 1 subnet 1 we have a virtual machine, and inside this VNet 2 subnet 2 again we have a virtual machine. Now, guys, the point is that these two virtual machines in these two virtual networks can, of course, talk to each other with their public IPs. Okay. But in the company environment, in the industry environment, public IPs are not a good idea. Like, from the security perspective, normally the resources are not granted the public IPs. So these virtual machines may not be given the public IPs itself, just from the point of security perspective. So during this case, when the public IPs are not granted to the virtual machines and you still want to make them communicate with each other, you still want these two virtual networks to communicate with each other. So you can actually do so with something called as VNet peering, in which if you establish VNet peering between these two virtual networks, if you establish VNet peering between these two virtual networks, then the VM from this virtual network can talk to the VM in this virtual network on their private IPs, guys, on their private IPs only. Okay, so they will not need the public IPs then, and this would be considered pretty secured way of communication, right? So the two virtual networks would be connected with each other as well, and they will be talking to each other using the private IPs only, right? So no public IPs would be shared this way, right? And still they'll be able to communicate with each other. So this is the beauty of VNet peering that you have got, guys, right? Okay, so now let me tell you few more things in VNet peering, and then uh, I will yeah, so let me tell you few more things in VNet peering. Yeah, I'll just close this. Yeah. Okay. So now, see, VNet peering, I'll just put it here and I'll explain you guys. I'll go to Notepad here. See, VNet peering, you can set this up between two virtual networks, right? So that is the first point. In case of a VNet peering, that is, you can set this up between your two virtual networks in Azure, right? Then, guys, the second point is that the your virtual network can be in the same region or can be in different region also, right? So the virtual networks that you will peer, guys, because see, guys, in cloud you have the presence of cloud across the globe, right? So your one virtual network can be created in one region and the other can reside in another region, and still they can peer with each other, they can connect with each other. So they can be in the same region, the virtual networks, or they can be in different region as well, and still you can connect them with each other, which is called as what VNet peering. And guys, if they are in the same region, then it is called as local VNet peering. If you are connecting two virtual networks in the same region, then it is called as local VNet peering. And since you have written if in the same region, and then it is called as local peering connection or regional VNet peering. So if your two virtual networks are in the same region and you are connecting them with each other, then it is called as local VNet peering or regional VNet peering. But if they are in different regions, guys, if they are in different regions, then it is called as global VNet peering. Then it is called as what? It is called as global VNet peering. Okay. So that is what. So if you have two virtual networks in different regions and you are connecting them with each other using VNet peering, then it is called as global VNet peering, guys. Right? So that is the point. Right? Then going ahead, I can put few more points here. Okay. Before that, I can also tell. Yeah. So going ahead, I'll put few more points here. So, guys, the CIDR blocks in VNet peering should be unique with each other. See, I'll tell you. See, if you have these two virtual networks, then their CIDR blocks, that is classless interdomain routing, that is their address spaces should be different, guys. Because if they are having the overlapping address spaces or the same address spaces, then the resources inside those VNets, the virtual machines inside those VNets can get the common IP addresses. And if they have the common IP addresses and you peer them up, so there can be a problem of duplicate IPs that you can face. So you can then face the problem of duplicate IP addresses. And that's why the two virtual networks should have the different CIDR blocks, that is the different address spaces, right? So CIDR blocks should be unique to set up the peering. And the traffic will flow over through the private network using the Azure's backbone network. Okay. So in case of VNet peering, guys, when you connect the two virtual networks, the traffic between the two virtual networks will flow over through the Azure's private network only and not over the internet, right? It will flow over through the Azure's private network only and not over the internet. So we have a question from Bozra Muhammad. So thanks for asking. He's asking, is it like the VPN? So Bozra, it is some. I mean, you can say it is like the VPN, but see, there is a difference. In case of a VPN, the traffic, if you have two virtual networks connected using a VPN, then the traffic will flow over through the internet. So you will have to encrypt the traffic, but here the traffic will flow over the Azure's backbone network, that is Azure's private network. So here you don't have to encrypt this traffic, right? And the communication can be really really quick here. Okay, Bozra, so that is one of the main difference. Then what is the other difference? Other difference is that, see, in case of VPN gateways, you can connect the two virtual networks that can be in Azure, or you can have one virtual network in Azure, one in your on premises, or one in Azure, one in a third party cloud, right? So you can have that. Okay. But in case of VNet peering, that is not the case. Here, the two virtual networks have to be a part of Azure only, right? So that is the point, right? Again, a difference that I can tell you here, right? So then we have a question from Aditya. Aditya asking that, sir, what is CIDR block? So CIDR stands for classless interdomain routing. Aditya, I will just tell you in brief. So with CIDR, you get the range of IP addresses. So see, if suppose this is your CIDR block, or for that matter, Aditya, I'll just write down, if this is the CIDR block, that is 10.104 .0.0/24. I'll just put it here and I'll quickly explain you. So this is giving you range of IP addresses. Okay. So this is giving you range of IP addresses. How it is giving you a range of IP addresses? Because guys, we know that IPv4 is a 32-bit addressing scheme. It is what? It is 32-bit addressing scheme. IPv4 is 32-bit, right? So in this CIDR block, something that is written after the slash is called as the subnet mask. Okay, something that is written after the slash is called as the subnet mask. Okay, so IPv4 is a 32-bit addressing scheme. So to calculate how many IP addresses will you get in this CIDR block, because I'm saying that with a CIDR block you get the range of IP addresses, right? So how many IP addresses you will get? So since IPv4 is a 32-bit addressing scheme, so 32 minus 24 comes out to be how much? It comes out to be 8, right? So this is going to become the value of n, and the formula to calculate the number of IP addresses in a network is given by 2 to the power of n. So 2 to the power of n is equals to 2 to the power of 8 here. And guys, can you tell me what is then 2 to the power of 8? So that is 256, right? So I can say with this CIDR block, which is having slash 24 as the subnet mask, you get 256 IP addresses in this network, right? So you get 256 IP addresses in this network, right? So is it clear to you, Aditya? See, I can tell you in great detail about the CIDR blocks and subnet mask. I can actually tell you how you can design your network, right, Aditya? But actually that is not in the scope of the discussion for today, right? So that is not in the scope of the discussion for the today. So that's why I have just tried to explain you in short. If it is clear to you or not, you can please let me know, Aditya. Yeah, that is great then. Yeah, sometime if we'll meet, I will give you such a good understanding on how you can what how you can uh, create your, I mean, how you can design your network right from what is CIDR block, what is subnet mask, right? I can tell you in great details, right? uh, yeah, yeah. So okay, just hold on. See, okay, then what is Azure's backbone network? Azure's backbone network, Shadab, means the private network of Azure, over which the two virtual networks will communicate with each other, right? So, since it's the private network of Azure through which all the data centers in Microsoft Azure are connected with each other, right? So, since it's the private network of Azure, so that's why the communication is very fast and very secured as well, right? Okay, Shadab, I hope that is clear. You can please confirm. Please explain difference between IPv4 and IP. So IPv4 is 32-bit addressing scheme, whereas IPv6 is not 32-bit addressing scheme, right? So that is the main difference that I can tell you here. So with IPv4, IPv6, you get more number of addresses, right? Vidya Nathan, is it clear? For two clouds, just network has to be the same. Uh, for two clouds, just network, no, the network can be different. Network need not have to be the same. See, anyways, for two clouds, the network would be different. And I mean, they would communicate anyways over the public network, Nihit, right? Is that clear? Then Niranjan asking, then what is the necessity VNet peering if we unable to connect over internet? And is VNet peering is applicable on Azure cloud or it can be on AWS cloud environment? So see Nihit, so see Niranjan, see VNet peering is very useful because see if you have, I mean, you tell me one good thing, Nihit. I mean, Niranjan, I'll tell you, sorry. Niranjan, see here. If you have got two virtual networks in Azure and the virtual machines, that is the resources in them. Now, you can communicate these virtual machines through their public IPs without having the peering or without having these two virtual networks connected with each other. But my question is, can you make these two virtual machines to talk to each other using their private IPs? Without having these two virtual networks to be connected with each other. Niranjan, yeah, can you make these two virtual machines to talk to each other using their private IPs without having these two virtual networks connected with each other? Ranjan, you cannot have it, right? You cannot do that. Now, the option now, see, if you have two virtual networks and you have not connected them, so you cannot make the virtual machines in them to talk to each other using their private IPs. Okay, so you cannot do that. Now, to connect these two virtual networks, you have two options. You can go with VPN gateway or you can go with VNet peering, right? But then if these two virtual networks are in Azure only, so why not to go with VNet peering? Why? Because see, in VPN gateway, it would be a connection over the internet. So the traffic will have to be encrypted. It will not be that secured and will not be that fast. Whereas in Azure, whereas in VNet peering, since the communication happens over the Azure's backbone network, Azure's private network, right? So that's why I can say the uh, communication need not to be encrypted because it is using a private channel, and then the communication can be really fast because it is using the Azure's private channel only, right? So there you get that advantage of using VNet peering if you have two virtual networks that you want to connect with each other and the two virtual networks are in Azure only, right, Niranjan? But if the two virtual networks, out of them one is in AWS or one is in Azure or one is in your on premises and one in Azure, then you can connect them using VPN gateways, not through VNet peering. Right, Niranjan? Is that clear? Right? VPN gateways make sense? Yeah, good. Yes, so that is what it makes sense, right? So of course, VPN gateway also, guys, we can discuss sometime if we take some session on VPN gateways as well, probably some next time, right? Um, Okay, so guys, private networks cannot be hacked. Yeah, that is true. I mean, see, there is very less chances of your private network getting hacked, right? I mean, almost zero, you can say, Ellie. Yeah, so that makes it very secured, right? So yes, guys, I hope I have answered all the questions till now, and hopefully all are good with the answers. Yes or no? Yeah. So yeah, okay, good. Thanks a lot for the confirmation. Yeah, and Ranjan. So, yes. So, guys, now see, I can tell you one more thing about this thing. That is, see, okay. So, I've already said you this thing that yeah. Let me put it here, and that would make sense. Or I can put just here. So, guys, as I said, peering is of two types: regional VNet peering and global VNet peering. So, in regional VNet peering, it connects the Azure virtual network in the same region, whereas global VNet peering connects Azure virtual network in different regions. So, when creating a global peering, the peered virtual networks can exist in any Azure public cloud region. See, Azure public cloud region only, or the China cloud regions as well, because guys, Azure has got a community cloud offering for Azure China that is called as Azure China Cloud, and for Germany's users also called as Azure Germany, right? So you can do a global VNet peering between any Azure public cloud region or between China cloud regions as well, but not in government cloud regions, guys. So it has got the offering for US government cloud as well. So you cannot do global VNet peering between government cloud regions because guys, that is because of compliance requirement. So I mean, of course, you don't want the two countries government cloud networks to connect with each other directly. That can be a what policy violation, right? So that's why that kind of peering with government cloud regions is not allowed. That is global VNet peering. So you can only peer virtual networks in the same region in Azure government cloud region, right? So
Uh,
that is there. Yeah.
First, Tom, I just
Yes.
wanted to make a comment about that. There is a movie from the 1970s called Colossus, the Forbin Project. And this was before the idea of cloud computing, but it does feature one notion of two government clouds talking to each other, and it does not end well for mankind.
Okay, great. In fact, yeah, so great to know that's true. And in fact, this is something that I have came to know from you now. Yeah, so added to my knowledge. Thank you. Yeah, and to you participants also. Yeah, a good information, piece of information. Yeah, okay. So guys, that is there. Fine. Which is the best cloud? That is again a question. So, see, I mean, I would tell you, you cannot actually say that one is the best over the other, right? This is a debatable point, uh, right? Um, so, this is basically a debatable point, Raghavendra. But I would tell you that I mean, as per the documentation or as per the knowledge or as per the Gartner also is concerned, Gartner is a research organization. So as per Gartner, if you'll think of, so Azure is better if you'll consider the PaaS-based services, platform as a services, and you can say AWS is better in IaaS quadrant, right? But Azure is fast growing, guys. So yeah, so I am good on both, and let me tell you, both are good. I mean, in their own way. So, but personally, if you'll ask me, I will tell you Azure, Microsoft Azure, to be a better one. Uh, yeah. So you can have different answers from, but logically, I'll tell you what they say is IaaS. It is AWS taking over, whereas PaaS-based services is Azure who is taking over, right? Yeah, what is the use of virtual machines, right, Raghavendra? So I hope this is good. Then we have Shadab saying, what is the use of virtual machines interacting with each other? See, Shadab, I will give you a use case here. Shadab, I mean, see, of course, if I'll tell you the two virtual machines may need communication and that's why they will interact with each other, all good. I mean, not a problem. But I'll give you a real scenario here. Let's say, Shadab, if you have your web application that is running on one virtual machine. So this one virtual machine is running as a web server, and you have your web application running on that virtual machine. And on the other virtual machine, let's say you are running a database server. And now, so your web app is your front end and your database is your back end. So now you want the communication between your front end and back end. So Shadab, if you want that, you of course want to communicate these two virtual machines, right? So this is, I hope this is good, right? So this is a pretty useful use case wherein you may want your virtual machines to interact with each other, right? Okay. So Niranjan asking, yeah, good. Yeah. Thanks for the confirmation, Shadab. So then one doubt from Niranjan. Niranjan saying that in VNet peering, is there any protocol used to talk to each other? Yes. So Niranjan, not exactly the protocol here, but yes, when you have to protocol means, Niranjan, see these. No, not exactly the protocol. Once you have them connected, so they will talk to each other with their private IPs. But then if you have to connect to the VMs from your virtual network, then you will need, maybe if it's a Windows VM, you will need RDP protocol. If it's a Linux VM, you will need SSH protocol, right? But not the two VMs to communicate with each other. You don't need a protocol there, right? Sir, is there, okay, I hope that is clear, Niranjan. Then Vanshika saying, sir, is there any disadvantage of global VNet peering? See, as such, there is no disadvantage. But then if there is, I mean, I'll give you a use case. Let's say if your company is having some compliance requirement, right? That like let's say if you are working for say intellectual property rights kind of a company, right, wherein the company data should not cross the country boundaries, right? And in that case, if you are on Azure and if you have created a global VNet peering, that is if you have peered your virtual network of the company with other countries virtual network, then you can lend in problem, correct? Because that is not allowed from your organization's perspective, right, Vanshika? I hope that is clear. Yeah. Thank you. Good. Okay. So, guys, I hope we are good till this point. So, we are good with the discussion on the two virtual networks. So, let's do the lab around this, right? So, in the lab, what we will do is we will create two virtual networks and the two subnets in them. And then, guys, we will create two virtual machines, one in the first virtual network and the other in the second virtual network. And then what? I will establish VNet peering between these two virtual networks. And yeah, so this is what I will show you, right? So I hope this is clear till this point. And then if this is clear, guys, then shall we go and do the lab? I mean, I'll just show you how you can do the lab around this, right? And you can do it along with, or maybe you can do it later on as well. So that should be good, right? So yeah, and these are the CIDR blocks that I'll take for my virtual network and the subnet, right? So virtual network one, this CIDR block, because of course you need to assign the range of IPs to your VNets, because you need to create the resources, the virtual machines inside that, right? So they will need the IP addresses. That's why. So I'll create this VNet, and inside a VNet, I can create multiple subnets. So subnet will be a part of your VNet. So that's why it will take an address space that is inside of your virtual network, right? So that is there. And guys, I will just demonstrate a global VNet peering for you. Let me tell you, as far as the connectivity is concerned, there is no difference between local or global VNet peering. The steps remains the same, right? It's just that when you have global VNet peering, you will have the two virtual networks in different regions. In local VNet peering, you will have the two virtual networks in the same region. So here we will have global VNet peering, in which I'll have my first VNet in East US and the second VNet in West US, right? And yeah, so that is how I will go about it, right? So we will have VNet 1 and we will have VNet 2, right? In resource group 1, and this in resource group 2, right? So I mean, whatever the resources that you are creating in Azure, you have to create it inside the resource groups, right? So guys, just tell me, and this is the IP that would be assigned to your virtual machine inside the virtual network, that is the private IPs. So, what is the term used for, like in the IP? What is the term used for that 24? So, this 24 is called as the subnet mask, right? And this complete 10.104.0.0/24 is called as the CIDR block. Correct, Shadab. And out of this, the IP that is assigned to your virtual machine, that is 10.104.0.4, that is called as the virtual machine's IP address. Right, Shadab? So I hope that is clear. Yes or no? To find the subnet mask. How to find the subnet mask? Okay, how to find the subnet mask? So see, you don't have to find the subnet mask, but you will have to decide a value for your subnet mask. And the value that you decide for your subnet mask will actually decide, Shadab, that how many IP addresses you will have in that network. Like I had given you the example here, if /24 is my subnet mask, then 32 minus, because IPv4 addressing is 32-bit addressing scheme. So 32 minus 24, the value you get is 8. And that is nothing but called as the value of, is nothing but the value of n, right? So the formula to calculate the number of IP addresses in a network is given by 2 to the power of n, that is 2 to the power of 8. It will become, that is 256. So here you will get 256 IP addresses, right? So based on your requirement, let's say if you own an organization and that needs that has 255 machines, or sorry, 200 machines, so it needs 200 IP addresses. So you can go with /24 as the subnet mask, because that will give you 256 IPs that can easily cater to those 200 machines. Correct or not, right? Understood, Shadab? Yeah, good. So why so much is IP addresses, please? Why so much IP addresses, please? So, Ellie, as I told you, let's say if you own an organization, and if you, like, say, let's say if you have a small organization, um, with say 200 computers, right? Yeah, correct, Niranjan. Yeah, so if you have um, uh, if you own an organization with say 200 computers only, right, Heli? And now you want the IP addresses for these 200 computers, right? So you have say company A or company 1 with how many sorry company 1, if with how many computers, let's say 200 computers, right? And then you want how many IPs? 200 IPs. So if you go with /25 as the subnet mask, the value of n will become how much? It would be 32 minus 7. So sorry, 32 minus 25, that is 7. It will become um, and then 2 to the power of 7 is 128. So 128 IPs cannot cater to 200 servers. So you need at least 200 IPs, right? So if you go with /24 as the subnet mask, you will get 256 IPs. So they are good enough. From these 256 IPs, 200 can be given to your 200 servers, right? Is that clear to you, Vanshika? Yeah? No, sorry. Is that clear to you, Heli? Yeah? I mean, why this much time spending in IP address issues? Okay. Uh, yeah, because see, that is the base here. I mean, you should have at least some understanding of on IP addresses because we are discussing about VNet peering here, right, Ellie? Sir, what is subnet one and subnet two? Subnets are nothing but the what you call it as. Let's say I'll give you a layman's example here, Vanshika. Like in your home, you have multiple rooms inside your house, right? So you can think them as your subnets inside your house, right? So your house is your virtual network, and the rooms inside that are the subnets. So similarly, like your organization is your virtual network, and the departments inside that are nothing but your subnets, right? Okay. Yeah, that is correct, Niranjan, in on premises, right? Uh, Okay, sir, what is subnet one? Yeah, so that's answered, I hope. Why most of people go with slash 24? Why don't use slash? So, Raghvendra, as I told you, if you want just IPs for 200 computers, if you go with slash 23, you will get 512 IPs. So, 512 can be a very big number to 200. So, you'll not need those many IPs. That's why it is good to go with slash 24, right? To have optimal design, correct? Right? Raghvendra, yes. Yeah, Suraj Kumar, you can also ask your doubt. Hi. Yes. So, guys, I hope this is clear. By the time you answer a question, you have any question, let me say this is clear. So then we will just go and we will implement this thing. That is, we will create two virtual networks inside them, two subnets, and then two virtual machines in that. Right? For the public internet communication, does IP address keeps on changing? See, if you have dynamic IPs, they will change. If you have static IPs, they will not change. Right, Nihit? Okay, fine. So, guys, shall we go and shall we now discuss, uh, do the lab? I mean, shall I tell you how you can do the lab on this? Yeah. So, can I get a quick confirmation? Sure. So, let's go and do that. What about others, guys? Can I please get a confirmation? Sure. Okay. Thank you. So I'm going in my portal, portal.azure.com. It's taking some time. I don't know why. Just yeah. So I am in my portal, and told me cloud software uses. See, there are a lot of uses, Suraj Kumar. So it can do anything that a on-premise software can do for you. Cloud software can do for you. If you want to know about a specific software, you can let me know which software. I'll tell you that, right? But whatever the softwares that you have in your on-premises, you can have it in the cloud, right? Okay, guys. So let's create the virtual network then, right? So I'll go to virtual networks, and I will create two virtual networks here. Okay. So I will create the first virtual network. So I'll say create a virtual network, and then I'll give the resource group name, because as I said that every resource in Azure has to be created inside a resource group. You can just say create new resource group, and you can just name it. You can just follow this document and name it. Let's say first resource group is RG1. So I'll give it a name, say RG1. Sorry, RG1. I'll say okay, and then I'll give the name of this virtual network, guys. So let's say I give it a name VNet1, right? And then I would like to say which region I want to create it. So let's say I can create it in what East US region, right? So I'll create it in East US region. Okay. So then I'll say next IP addresses. So now I'll take the IP addresses here. So the first VNet, I'll give this IP address range. That is the CIDR block, IPv4 address space. That is the CIDR block. So 10.104.0.0/16. So I'll just replace this default CIDR block with that block 10.104.0.0/16. And then, of course, the subnet inside that. That is like you have your organization inside that, the department. So you will give the subnet name and the subnet CIDR block. So let's say the subnet name I'm giving as subnet 1, and what? The CIDR block of the subnet as 10.104.0.0/24, which is inside of 10.104.0.0/16, right? So let me give that. So I've given that. So this will give you 251, 251, 56 overall IPs, right? So I can add this subnet, right? And once I've added this subnet in this virtual network, guys, then I'll create this virtual network, right? So virtual networks address space and then the subnet address space. And I say review and create, and I'll create this virtual network. Here, East US region means the Azure data center established on East US. Yes, correct. So it will create a virtual network in the data center that is in East US, correct? And validation passes, and I'll create the network. So can you please recommend some books to study in detail? Sure, Aditya. I will pass on that information to you, maybe through the Spock itself, right? Can we use Azure also for free, like AWS free tier? Yeah. So here you don't get 1 year for free, but you get $200 for 1 month free, Raghavendra, right? And after that, also there are many services that are free. Right? And Aditya, I'll pass on that information, the Azure books that can be useful. Of course, first of all, please recommend the Microsoft documentation for this on all the topics they have this. Plus, apart from that, I will share the information about the books to your Spock. I mean, they will just inform you about that, right? I hope that should be good, right? Thank you. Yeah, you're welcome. So we have created our first virtual network. Similarly, we'll create the second virtual network. So I'll go to virtual networks again, guys, and let me create the second virtual network in say second resource group. Let's say RG2. I'll give the name as VNET2, right? And then what? In West US. So in another region, I'm creating it. So guys, now I have a question to ask you. Can you please answer this? So I am having first virtual network in East US, and the second virtual network, I am creating it in West US. Now you tell me, if I will peer these two virtual networks, if I'll connect these two virtual networks, so this peering will be called as global VNet peering or regional VNet peering. Two virtual networks in different regions. Ellie, regional or global? It would be global, right, Ellie? Yes. So this would be global VNet peering. Correct, guys. So thanks for listening to me. Yeah, that gives me a confirmation that you are listening and you're good till this point, right? So I'll give the CIDR block to this virtual network 192.168.0.0/16. Uh, so I am giving this. Now the subnet name, I'll just name it as subnet 2. Let's say subnet 2, and I'll give the CIDR block for this. So I can go by the example that I've taken here, 192.168.0.0/24. Okay, and I'll add it. And then I'll say review and create, and I will create this virtual network as well, guys. So what we have done, we have created one resource group in that one virtual network and one subnet, another virtual network with a resource group and a subnet in that. Till this point, we are done, guys. Now, what would be the next step is to create what? To create the virtual network peering between these two virtual networks, right? So I will create the peering between these two virtual networks now, right? And then I will create the two virtual machines in these two virtual networks. Or I can do the vice versa also. That is, I can create first the two VMs in these two virtual networks and then the virtual network peering between the virtual networks. So whichever way you want, I can do that, guys. Right? So let's say we will create the two virtual machines in those two virtual networks first, and then we will establish the peering. Okay. So yeah. So you can create first the virtual machines and then establish the peering between the networks, or you can first establish the peering between the networks and then you can create the two virtual machines also in the networks, right? So I'll just go and I'll create the two virtual machines first. So you can search here for virtual machines, and when you get this, you can say create a virtual machine. Okay, so that virtual network got created there, and I'll create the first virtual machine inside the first virtual network. So I'll have to put it in the same region as my VNet one is in. Otherwise, I'll not be able to put it inside VNet one. So I'll create it in East US where my VNet one is in. So in that same resource group, I will create the first VM. Let's say VM1. Okay, and or I can say East US VM1, because this I am putting it in East US region. So I'll say East US because I want to put it in the same virtual network as my East US virtual network is in, VNet 1 is in, right? And then I will select the operating system for this virtual machine. So let's say I go with Windows Server 2016 data center. Then this will decide the size for my virtual machine. So D2S V3, this is a naming convention that will give you two vCPUs and 8 GB of memory, right? And then the username and password for your virtual machine. So guys, you can give any username and any password to your virtual machine, right? So, but if you have to connect to your VM, you need to remember this username and password. That is the point. Then what? Allowed selected ports. I can say RDP. If you have to connect to your virtual machine, you'll need RDP port to connect. That works on port 3389. Right? That's it, guys. That's it. And I will say, no, I will go next and I'll see this is the hard disk that would be used for my virtual machine. So I'll go with the default option for that. Right? So we have a question here that is, can we create virtual network in AWS? Yes, you can, Vedansh. So where that is called as a VPC service in AWS. If you have to create a virtual network in AWS, it can be created through a service called as VPC, Virtual Private Network. Right, sir? Where are we creating virtual network? We are creating it on Azure, Aditya. Right? Is it on a server? Yes, it would be created on a physical server only, Aditya. It will use the resources of your physical server. Right, Aditya? In your data centers out on the provider end. What is RDP port? RDP stands for Remote Desktop Protocol. That works on port 3389. Shadab. So actually, basically, you have ephemeral port range that ranges from 0 to 65535. That is, you have 65536 ports. Okay. Out of which, see, every protocol is assigned a port number in your machine. So RDP works on port 33, RDP works on port 3389, right? So that is there. Like your HTTP works on port 80, or HTTPS works on port 443. Likewise, your RDP works on port 3389. It is there to connect to your, if you have to connect to your Linux, Windows virtual machines from your laptop, you can connect it through RDP port, which works on port 3389. If you have a Linux machine, you can connect to it using SSH port, which works on port 22. Sir, I'm a student and I want a suggestion whether DevOps engineering is worth for future. It is worth valuable. I would say, Vanshika, because DevOps is has become the present also, and it is the future also. So it is having a lot of scope. Yeah, and if you do DevOps in Azure, DevOps in AWS, that will also add to your value, right? Is there any security groups need to create in Azure to connect to virtual networks? Same as in AWS. See, security group, we don't need here. It's just that if you have to connect to your virtual machines here, you will need the security groups, the inbound port rules. As I said, that I'm allowing the traffic to go from, I'm allowing port 3389, that is RDP port, so I'll be able to connect to my virtual machine. So that means I'm allowing traffic from 3389. So that in the security group we are specifying for the virtual machines. Otherwise, no, right? So this is there. So this is the hard disk. So I'm good with the default option. Then I'll go networking, guys. And I need to make sure one thing, that I get that VNet one and get that subnet one. So guys, you cannot see that VNet one and subnet one here. That is basically an Azure bug. You should be able to see it being in East US. So don't worry, you can be able to see it, but you'll have to refresh it and come back again here and see RDP port. So incoming traffic allowed from RDP port. So that is a part of network security group, right? So it is there this way, right? Okay, so anyways, I'm not able to see that VNet 1 here being in East US only. So I'll have to again refresh this maybe, and I'll have to again connect to the virtual. I'll have to again try to create the virtual machine, right? Is VNet peering better to VPN? Are both comparable in any way? So, Karthi, I've already said you can say it is better in the sense because it uses private IP addressing for the communication between the two virtual networks. Because it will use the private channel, that is the Azure's backbone network for communication. So that's why it is more secured, more fast, and that's why it can be termed as better than VPN gateways if you have two virtual networks to be connected in Azure only, right? Okay, then so how about we need to access internet to VNet? So how about if we need to access internet to VNet? See, you want one virtual network to connect. So if you want your VM from one virtual network to connect to the internet, anyways, it is has the public IP, so it can connect to the internet. So that is not a problem, Mohammed, right? So if it has to connect to internet, the VMs and these resources on your virtual network, if they have the public IPs, they can connect to the internet. Correct? Which degree is most necessary for DevOps? DevOps, you can go with DevOps engineer. That should be good, right? Yeah, I hope that is clear. Yeah. Okay, fine. So let's try to create this virtual machine again, maybe. Right. So here I can give the resource group name as RG1 and then the VM name. Let's say VM1 I give it, right? In East US. And let me see if I can see that in networking now. Yeah, so you can see that VNet one now. So that is all good. So RG1, VM1, East US. Yeah, and I can select the uh, OS Windows 2016 size is good. Username and password I'll provide. And then I'll say next test. This is good. The next networking. So I'm in VNet 1 and subnet 1, wherein my VM would be created. So that is all good, right? And I can say review and create. And I can create this virtual machine, guys. So similarly, you'll have to create the second virtual machine in West US, right? So you'll hit on create. Yeah. So Karthi saying if data routed through VNet is unencrypted and we connect to public network, won't that be a data threat? See, anyways, the data that would go over through your VNet to another VNet, that will go, if it is unencrypted also, that will go over the Azure's backbone network private channel, right? So that will not be unsecured. But on your VM, if you have given the public IP, then you can connect to the internet. But if you have given public IP on your VM, that is anyways unsecured, right? So, but if you have to connect to the internet, you will need the public IP. Otherwise, don't give the public IP. So then your VM will also be safe. But this communication between this VM and this VM would be safe here because it will happen through the private channel, right, Karthi? Even if your VM has public IP, but this communication will happen through the private IP only, right, Karthi? Got it? Good. Yeah. So, guys, this is creating this virtual machine. All right. Now I'll create the second virtual machine till that time. Right. So I'll go to create virtual machine again. And this time I will put it in RG2 resource group. I'll name it as VM2. Right. And I will say I want to create it in West US. Right. Okay, I'll see if I can see that VNet 2 in networking. No, I'm not seeing that, so I'll have to refresh it. Maybe I'll have to come back again, or I can go here and then come back. So I'll say create a virtual machine. I'll give it a resource group, let's say RG2, and let's say VM2 in West US. Let's say I create it. West US. I'll just see networking. So I'm still not able to see that VNet 2, right? So I can just close it and come back again here. It takes some time, guys. This is a bit on the Azure bug end from the portal, right? Sometimes you don't see it, but if you have that VNet in the same region, you will eventually see it. Okay. So I'll just try to. So I'm just going to put it in West US. Let me see it in networking. Yeah, now I can see VNet 2. See, I didn't make any change. It's just that sometimes you don't see that VNet because of an Azure bug that they are facing in a month from last 1 month. But that's not a problem. After refresh, you get it, right? And then let's go to another Windows server. Let's say that one. Size and then username and password for this VM. RTP is good. Next disk, we are good with this default option for the hard disk. And next networking, we are good in this because we are in VNet 2 subnet 2, and this VM should be created in VNet 2 subnet 2. So we are in there, and we will say review and create, and we will create this virtual machine, guys. Validation passes, and we will create this virtual machine. Sir, in size, why is the 6,000 rupees per month? Because that is the cost that you'll have to pay for that size of the virtual machine. I mean that virtual machine, right? If you are not in the free tier, I mean if you don't have the Azure credits, then per month if you run that virtual machine, then that much amount you'll have to pay for that size of the VM, right, Shadab? Right, so this VM also getting created, right? So we have guys created VNet 1, subnet 1, and a VM in that, VNet 2, subnet 2, and a VM in that. Now, let me tell you how you can establish peering, right? So go to your virtual networks. You can go to any virtual network. Let's say I go to VNet 1. Let's say I go to VNet 1 and I will say what? I will say peering here. So going in one virtual network, you can actually establish the peering both ways. That is from VNet 1 to VNet 2 and from VNet 2 to VNet 1 as well. So you can say peerings here and you can say add peering. You can say add peering and you can give the peering link name. So you are in VNet 1. So the first you want to peer VNet 1 to VNet 2 first, so you'll say VNet 1 to VNet 2. You can give any name, guys. That's not a problem. So I'm just saying VNet 1 to VNet 2. Now traffic to remote virtual network. This is like saying, do you want to allow the traffic from VNet 1 to VNet 2? So guys, should we be allowing this or should we not be allowing this? Tell me. So, sir, to do this, we have to create Azure account. Yeah, or you need to have access to the Azure account only. Correct? So we should be allowing Shadab, correct? Because we should be allowing because we want the communication from VNet 1 to VNet 2. So we will say traffic to remote virtual network allow. Now traffic forwarded from remote virtual network. Now for VNet 1, which is the remote virtual network, it is VNet 2. Then it is saying traffic forwarded from remote virtual network. So this is saying like guys that you want forwarded traffic from VNet 2 to VNet 1 or not. Now see, forwarded traffic is not the normal traffic. I'll tell you. I'll show you this diagram and I'll tell you. See, a traffic from a VNet is called a forwarded traffic if that traffic is not generated on that VNet. Let's say if VNet 2 is sending some traffic to VNet 1 and then VNet 1 is sending that traffic to VNet 3. So this traffic VNet 1 has sent to VNet 3 that is not generated by VNet 1 but that has came from VNet 2. So this traffic from VNet 1 to VNet 3 is called as the forwarded traffic, guys. That is a traffic that is being given from one VNet to another VNet, which is not generated on the first VNet, but it is just got that traffic from some other VNet and it is forwarding it to some other VNet, right? So here is VNet 2 receiving some traffic, say from VNet 3 and VNet 4 or VNet 4 that it has to give it to VNet 1, guys. Do you have something like this in this particular diagram? Do you have something like this? That VNet 2 receiving some traffic from VNet 3 and VNet 4 that it has to give to VNet 1? No. So forwarded traffic should be allowed or should be blocked? Tell me. It should be allowed or it should be blocked? It should be blocked. Yeah. So I'll say block. Yeah. Sure, Lassa. I think they'll upload it, so that should not be a problem. Virtual network gateway or route server. So see, this is a direct connection. So there is no route server in between we want. So this is none, right? So this is peering from VNet 1 to VNet 2. Now let's peer the other way around. That is from VNet 2 to VNet 1. So again, you can do it from this end only. Like being in VNet 1 only, you can peer from VNet 2 to VNet 1 also. Right, guys? So VNet 2 to VNet 1. Yeah. So now, see, then we are in resource manual. That is all good. So now virtual network. So which is the virtual network from where I want to peer? So that is what I should see here. VNet 2, correct? So, but then I am not seeing this VNet 2 here. So now I can see VNet 2. So I want to connect from VNet 2 to VNet 1. So the virtual network that I want to be in is VNet 2, right? Now from VNet 2 to VNet 1, do you want to traffic to remote virtual network? Will you allow or will you not allow traffic from VNet 2 to VNet 1? Guys, tell me quickly. Allow or block traffic from VNet 2 to VNet 1. Tell me quickly. Allow, correct. Yeah. Okay, so I'll allow. Then traffic forwarded from remote virtual network. So for VNet 2, which is the remote virtual network, it is VNet 1. So guys, forwarded traffic from VNet 1 to VNet 2. It should be block or allow. It should be block, correct. Why? Because VNet 1 is not receiving any traffic from VNet 3 or 4 that it has to forward to VNet 2, right? So forwarded traffic is a traffic that is not generated on the VNet, but it has received from some other VNet and that it has to forward to some other VNet. So here it should be block, right? And of course, it's a direct connection, so no route gateway or virtual network gateway or route server. So I'll just add it. And this has added the virtual network peering, guys. So this has added the virtual network peering between the two virtual networks. Okay, so we are done with this complete scenario here. This one, that is, we have created one VNet subnet and a virtual machine in that, another VNet subnet and a virtual machine in that, and we have actually connected our two virtual networks with each other, guys. So now the VMs can talk to each other with their private IPs, right? So that is all good. Now, guys, okay, so now is there any advantage of virtual network which was peered first, sir? Is there any advantage of the virtual VNet which was peered first? So we have peered first VNet to another VNet, second VNet to first VNet. Yes, there is an advantage because if the VNets are peered with each other, the resources, the virtual machines in them can talk to each other using their private IPs, right? That is the greatest advantage, Aditya, you got, because it is a secured way of communication in your organizations, because in the IT organizations, normally they don't allow the public IPs on the virtual machines from the security perspective. And now with the private IPs on the virtual machines, they can still communicate with each other if you have VNet peering established.
Prashant,
Yeah.
is there, I think part of the question was, is there any priority assigned to the network that was chosen first in the peering, or are they both equal in?
Okay, priority.
priority?
No, both are equal. Both are on the same level. So there is no priority as such, right? So if you do the peering from VNet 2 to VNet 1 first, and then from VNet 1 to VNet 2, or the reverse, I mean, it is the same. I mean, there's no priority as such, right? And there is no advantage if you peer VNet 1 to VNet 2 first, and then VNet 2 to VNet 1, or VNet 1 to VNet first, and then VNet 1 to VNet 2. So it is the same. Correct? I hope that is clear now. Yeah. I hope, Stuart, I've got it right now. Yeah.
Yeah, and Aditya says it's clear as well.
Yeah. Then why is VNet only forwarding? Why is VNet only? See, VNet is not only forwarding. See here, in our case, the VNet is not sending the forwarded traffic. So VNet one will send the traffic that it has originated from VNet one only. That it will send to VNet two. So a traffic that is coming from some other VNet to this VNet, and that something like this diagram I've drawn it for you guys. So if VNet 1 is receiving some traffic from VNet 2, and that it has to give to VNet 3, then it will be called as the forwarded traffic from VNet 1, right? So it is not just about the forwarded traffic. VNet 1 may have some traffic that is generated on VNet 1 only, that it has to forward to VNet 3, and it may have some traffic that comes from VNet 2, and that it has to forward to VNet 3. So the traffic that is coming from somewhere else, and that it has to forward to VNet 3, that is called as the forwarded traffic. But the traffic that is originating on VNet 1 only, that is not called as the forwarded traffic, which is going to VNet 3 then, right? So yes, Ellie, is that clear? Which one will be better, VNet 1 to VNet 2 or VNet 2 to VNet 1, sir? I mean, it is the same, Aditya. Nothing better. I mean, it is the same. Whether you go with VNet 1 to VNet 2 first, and then VNet 2 to VNet 1, or VNet 1 to VNet 2 to VNet 1 first, and then VNet 1 to VNet 2, exactly the same, right? Why is VNet? Yeah, so I hope that is clear, Ellie, now. Okay, sir, now it's crystal clear, Aditya saying. Ellie, okay, yeah. Ellie, is it crystal clear to you as well? I hope yes. If not, you can ask me again. That's not a problem. Okay, so yeah, so we have connected this, guys. So I think I have, yeah, clear, good. So this is good. Now, see, and you can see the status, it is connected now. So guys, it is done. So if you are in VNet 1, you can see VNet 1 to VNet 2, it's connected. If you go to VNet 2, that is your second virtual network, and there also if you go to the peerings here, so you will see this connected. Yeah, so this is also connected. So guys, this is actually the end of the lab. But now, if I think we are good. But then if you want me to show you whether the two VMs are connected with each other, or to make the two VMs to reach to VM1 from VNet 2. If you want to test it out, I can show you. Right, you can ping them, or directly also with the network watcher tool. I can test this out for you guys. See, we are done with the lab. If we have that time, I would like to ask Stuart, do you want me to show? Is that we should go with, or we can just anyways, done for the day. Yeah, Stuart.
If it only takes a minute or two, then you can show it, but that's up to you.
Yeah. Okay. So it is good for with you now. I mean, if I do it, yeah, that should not be a problem. Yeah. Okay.
Yes,
So
that's good.
okay. So I will just try to show it now. Right. So yeah, so please show. People are saying. So let me show. So what I can do is I can probably connect to the two VMs, and I can show it, or rather with a network watcher tool also, I can just try to show it to you. If network watcher tool works, it would be faster. So I'll try to do it with the network watcher tool. So guys, network watcher is a monitoring tool that can be used to monitor your resources, right? So in network watcher tool, um, you can go to connection troubleshoot, and then you can try to ping from resource group RG1 virtual machine VM1. You can try to connect to VM2, so you can specify manually the private IP address of VM2. See guys, I'm giving the private IP address. So from VM1's private IP, I'm going to connect to VM2's private IP. So for that, I'll need the VM2's private IP, so I'll get it. So I'll go to the VM2, and I will just get the IP of VM2. So that is 192.168.0.4. So I'll just get that, and I will just give it here. And then what I'll do, guys, I'll say I want to try the connection on port 3389, that is RDP port, so TCP connection. So I'll just say check. And guys, when I'll say check, it will take its own sweet time, and then it will show me the output as connected, right? Reachable. The output it will show me as reachable. Yeah, because the peering is established. If the peering would not have been established, then this output would have came as unreachable, right? Because now we have the peering established, so the connection from VM1 to VM2, we should see it as reachable. Similarly, I'll duplicate this tab and I will test the other way around also. See unknown error. So I will again check back again. So it takes its own sweet time. And yeah. So is this VNet connection keeps charging if we don't disconnect even the VM? So the resources we will have to terminate, otherwise we'll keep on charging. I mean, otherwise it will keep on charging. Yeah, VMs also will have to shut down. Can complete resources be shared in VNet peering? Yeah, then all resources you can share. That is not a problem. Is it through ping? We can do it through ping also, Murli. Or this is also a way of testing the connection, right? Or you can connect to the VMs and you can use the ping command also to test it out, right? So now I'll try to get it from the second to first. So I will try to do the connection troubleshoot from RG2 virtual machine 2 to, it is basically, this is from where to where, this is from VM1 to VM2. So now I'll try to do the connection from VM2 to VM1. So I will specify the IP address of VM1, that is the private IP of VM1. So I'll go to VM1 and I will get the private IP of VM1, that is 10.104.0.4, and I will just give it here. Okay. Uh, there is a space, I think. Yeah. So I'll test it on port 3389 because both are Windows VMs anyways, and I will say check. So this will check the connectivity from VM2 to VM1, and the first one will check the connectivity from VM2 to VM1 to VM2, right? It takes its own sweet time, guys. So it is checking the connectivity, and the other one will do the connectivity from VM2 to VM1, and the first will check the connectivity from VM1 to VM2. So if VM1 is connected, is reachable to VM2, that means VNet1 is connected to VNet2, and if VM2 is reachable to VM1, that means again VNet2 is connected with VNet1, right, guys? So I'm just holding for this to reply, right? Again, I'll have to say this because, see, this is a network watcher tool. I mean, this is a monitoring tools. Sometimes it has bugs also in it, so a bit of there, but so it can time out initially. So that's not a problem. You can say check again. It takes some time to give you the answer, right? So yes, guys. So I hope it is clear till this point. Yeah. If you have any queries, you can ask me. Basically, this is the last thing that I want to show you here, right? If we see disconnected, yeah. So everything you should actually, yeah. Of course, if you don't shut down your VM, you will be charged for that. So you should shut down, and rather, if you shut down, also you will still incur the storage cost, right? So what you should do is you should delete the VMs, right? So I mean, rather than just shut downing your VMs, I mean, if you shut down, you will not incur the compute cost, but you will still incur the storage cost. But if you don't want your VMs, then you can just delete them. Then you can just do what? You can just delete them, right? So that is what you can do, right? Yeah, so that is there. So it's still checking for the connectivity. Yeah, so you can see, guys, we have the output. Yeah, so you can see here. See, it's successful, reachable, guys. Yeah, So this is VM1 reachable to VM2's private IP, that is 192.168.0.4. You can check for VM2's private IP also. That is 192.168.0.4. It is 192.168.0.4. Right, guys? So it is reachable, right? And you can just see the topology view as well if you wish to. Yeah. So you can see VM1 reachable to the virtual machine in the second virtual network, right? So this is reachable, guys. Okay. So this is reachable. Okay. And then the other way around, again, I mean, it would be reachable, but then, of course, you will have to do what? You will have to check the connectivity again, right? Yeah, so the other way also it will show you, right? So this is how it goes. I am what Muhammad is saying. I'm currently studying AWS. Can you advise me which is better and easy to study, AWS or Azure? It seems like Azure is much easier to learn than AWS. Yeah, Azure is easier. In fact, AWS is also easy, Muhammad. I've studied. I mean, I'm good at AWS also, so I can tell you that. But frankly, telling you, I mean, I feel like Azure a bit more easier than AWS. You can say. Yeah. And right now I mean, what is my personal experience is like I can see more value coming up for Azure now. I will not say not for AWS, but then um uh, I mean, being a corporate trainer and involved with corporate trainings on AWS and Azure also, I get more on Azure right now than probably the AWS market, right? So AWS probably many people are in, and Azure, not many people are good at, you can say, right? So that way, you can say you will get more value into it, I hope.